Hey everyone, it's Bennett Townsend, and I am going to be going over PostgreSQL. I think that's how you say it for this unit for class. So first, PostgreSQL is a database, and it's an open source relational database management system, and it's widely used for large scale data processing and storage. It provides support for SQL transactions, triggers, and stored procedures, and really kind of making it a versatile and flexible solution for managing your data. So PostgreSQL is designed to work with a wide range of operating systems, including Linux. It's also compatible on Windows as well. And just specifically Linux users, they can install PostgreSQL, which is relevant for our class because we'll just be installing this database on our Linux box. And you can install it using a package manager, or actually by building it from source as well. So for this class, I just use the package manager. It's much more user friendly. So PostgreSQL offers a variety of features that makes it a popular choice for database management. Database management can get fairly complicated, and PostgreSQL helps you manage that complexity. So ACID or ACID compliance is one of those features, and it ensures that transactions within PostgreSQL are completed in a reliable and consistent way. Extensibility allows users to create custom functions, operators, and data types, really kind of making it easy to tailor the database to any specific needs that you're looking for. And then obviously there's performance. So PostgreSQL is known for its scalability and its performance, which really makes it a good choice for any large scale applications that you may be using it for. And then there's also security. So really for any application, security should be a top feature. And Postgre is no exception, and it takes security as as a high priority. And the database, what it does is it backs up those Postgre backs up there's high priority security measures by providing strong security features, um, such as including support for SSL encryption, different types of authentication mechanisms, and access controls as well. So many Linux distributions include PostgreSQL in their package repositories. So the installation process should be fairly easy. Um, and you'll just, using the distributions package manager. So, for example, on Ubuntu or and Debian, you can install the Postgre SQL by running sudo apt-get install PostgreSQL. And what it'll do is it'll install the package for you based on the package manager. You do have the option for building it from source as well. As I mentioned, this is a much more technical, but you can get um, much more custom to your environment. So if your Linux distribution does not include possibly PostgreSQL in its package repositories, or if you just, as I mentioned, prefer to build it from source, you can download the source code from the PostgreSQL website. And to build from source, you'll need to have the following packages installed on your system. There are requirements. So GCC or any other C compiler, GNU Make, Perl, and zlib are all required to um, use the source code or install PostgreSQL from the source code. So a couple more features regarding PostgreSQL. So after it's been installed on your Linux machine, you will need to configure it to meet your needs. So Postgre has a configuration file, and it's located at etc PostgreSQL and then version and then main forward slash PostgreSQL.conf. And the version can be found a couple different ways, um, and that's really only the variable that changes. So a couple features that you may want to configure after installation is listen addresses. So by default, PostgreSQL will listen on all available network interfaces. So if you want PostgreSQL to listen on certain interfaces, you'll have to or you can specify them um, within those listening addresses. There's also memory settings. So PostgreSQL, it uses shared memory area to store data and any metadata. So you may need to adjust the memory settings to ensure that it has enough memory to perform well. No one wants a database that's bogged down because the resources aren't adjusted correctly. It can result in lost data and issues within the PostgreSQL databases themselves. So make sure the resources are set. Postgre also on their website, it has recommended resources um, for size as well. And then you also have authentication settings. PostgreSQL provides several different authentication methods including password-based authentication. There's also peer authentication, which will use the operating system's user ID, and there's also certificate-based authentication. So just a few security measures, as I mentioned before. So once you have PostgreSQL database installed and configured, you can create a new database by running the created command. So for example, to create a database called my database, you can run created my database, and by default, the new database will be owned by the user who created it. But it can be used, or sorry, it can be changed by using the -o option. Um, Also in Postgre, each user account has its own set of permissions and access controls. So to create a new user, you can use the create user command. All of these should be once you log into the Postgre SQL interface. I do need to preface that. So to create a new user, you can use the create user command. So for example, create a user called, if you wanted to create a user called default user, you can run create user and then enter default user or whatever username you want to use. And by default, the new user will not have any special privileges or access to any databases, but permissions can be granted to specified databases by running grant all privileges on database. My database to default user. So PostgreSQL is a powerful and flexible database management system that is well suited for any large scale data processing and storage. So it is compatible, as I mentioned, with a wide range of operating systems, including Linux, and can be installed using package managers or by building from source. So once installed, Postgre can be easily configured to meet any specific needs you may need, and you can create database and users to manage that data. So a few hardening recommendations I found. First is to configure Postgre to use SSL by modifying the Postgre SQL.conf file. So more or less ensuring the traffic, and as we've touched on before, ensuring the traffic is encrypted using SSL, it's almost always a better option to enable it. So again, if your traffic was to be intercepted, the person intercepting the traffic will see the traffic, but it will be encrypted and will be unable to make out what the traffic includes. So to execute this, you'll have to use a certificate authority certificate or CA certificate, or maybe use one that's already created. And then you'll navigate to the PostgreSQL.conf file using any text editor. Um, the actual file path is etc/etc/post GraySQL / and then that version that you're able to find /main /postgresql.conf. Um, and let's see, what you'll do is you'll scroll down within that config file where it says SSL equals on, and you'll uncomment that section. And then you can also set the certification files and the key files that are created when you create that CA certificate just below that, where SSL underscore cert underscore file equals insert the CA certificate file path, and then underneath that is SSL underscore key underscore file equals, and then insert your key for that CA certificate. Another recommendation is to enable log collecting. So enabling the collection of logs will track the activity on the database and make auditing the service much easier. So if an issue does occur or exists, the logs could become extremely valuable in finding how the issue occurred or where maybe it originated from. So to enable the logs, you must navigate to that same Postgre configuration file with any text editor, and you can scroll down to reporting and logging section, and you'll uncomment the logging collector equals off, and then simply just change off to on. As you navigate further down, you'll see there are further configurations of the logs, such as how long you want to collect them and or the size of the log file before recycling the old activity. And you can also dictate the log file name and or location. And then lastly is limit permissions and set user passwords to access PostgreSQL. So it's important that the necessary users are assigned the appropriate roles within PostgreSQL, really to limit access to only what's important to complete a specific job or maybe based on that user's specific responsibility within the database. So it's also important to obviously set unique passwords for each user to access Postgre. So users are only able to access via their account, and their specific activity will then be logged only for their specific actions tied to that account. And obviously, if you do an audit, you can see what they've done, or maybe audit a specific event and see where it originated from or who it originated from. So first step is you must create a role within Postgre, which requires you to, again, log into the PostgreSQL interface and then run the command I'm sorry, run the command create role and then define what you want to name that role, such as new underscore role. And then from there, you'll limit or specify the permissions for that certain role, such as granting permissions to certain databases or maybe granting permissions to certain tables in databases. And then from there, you'll create a new user and you'll require a password and then set a predefined unique, strong password for that account. And then you can provide that information to the user and make sure that information is not shared. So that's everything I found on PostgreSQL. Here are the references for my information. And as always, I look forward to seeing what other classmates found and your opinion on what I found. Thank you.